Welcome back to The Explainer. Today, we're basically turning our space here into a Web3 command center to secure your digital wealth. You know, if you're out there navigating the decentralized web, you are acting as your own bank. And, well, with that immense power comes some pretty immense responsibility. So, we're going to be breaking down the unforgiving architecture of blockchain transactions and giving you the exact step-by-step protocols you need so you never lose your assets to a simple operational error, or worse, a silent hack. We've got a really highly structured briefing to get through today. We're covering the unforgiving rules of Web3, network mismatches and memos, invisible threats like Clipper malware, address poisoning, the fail-safe sender protocol, and finally, how to truly lock down and secure your digital vault. Let's just dive right in. Starting off with Section 1, the unforgiving rules of Web3. We really have to start with this foundational reality of blockchain tech because any misunderstanding here can literally lead to total asset loss. When you compare legacy finance to Web3, it is night and day. Unlike the old systems, blockchain transactions are peer-to-peer and totally irreversible once they're confirmed. Think about it. In the traditional banking world, if you accidentally wire money to the wrong account, what do? You call customer support. They place a hold, reverse the charge, and you breathe a huge sigh of relief. Web3 is fundamentally different. As the support docs from Bitcoin.com spell out perfectly, once a transaction is recorded in a block and added to the chain, it's immutable. It cannot be changed, it cannot be reversed. There is absolutely no central organization or support desk that can undo what's been done. So, zero. Zero is exactly how many chances you get to fix a confirmed transaction error on networks like Bitcoin or Ethereum. If you send your funds to the wrong address, or even just the wrong network, your only hope is that you happen to know the recipient and they willingly send it back. Otherwise, those funds are gone forever. This permanent finality is exactly why our execution has to be flawless. Moving right along to Section 2, network mismatches and memos. This is our first major operational threat vector, routing your funds to the wrong place purely because of a network mismatch. Let's break down why sending an asset on the wrong chain is a permanent disaster. A wallet address format, like the Ethereum Virtual Machine's 0x format, can actually exist across multiple independent blockchains. We're talking Ethereum mainnet, BNB chain, Polygon, Avalanche. So if you try to send ERC20 Tether directly to a BEP20 recipient address on the Ethereum network without using a proper bridge, the network isn't going to stop you. But those tokens, they'll be permanently locked or lost in the void. Notice how different chains have distinct cryptographic signatures. Legacy Bitcoin starts with a 1 or a 3, Tron starts with a T. Identifying these patterns is absolutely your first line of defense. And what about memos? Well, if you're depositing assets like XRP, XLM, or Stacks to a centralized exchange like Kraken, omitting a destination tag means your deposit might become completely irretrievable. Here's how these centralized exchanges actually work under the hood. They don't create a brand new, unique wallet for every single user on these specific networks. Instead, they use a massive single pooled wallet address. Kraken, for instance, uses one master address for all XRP deposits. To figure out which specific user account gets credited, they require a unique 10-digit destination tag. Forgetting this tag is literally like addressing a letter to a massive apartment complex, but totally forgetting to write down the apartment number. The mailroom has your package, sure, but they have absolutely no idea who it belongs to. All right, Section 3, invisible threats, Clipper malware. Because sometimes the mistake isn't even human error. Sometimes your own device is lying to you. As MetaMask's Help Center points out, clipboard hacking exploits the basic copy and paste function to rob you. These malicious scripts run totally silently in the background, making your device's most basic function incredibly dangerous. Think about it. Crypto addresses are long and complex, right? Nobody is memorizing them. We all rely on copy and paste. Hackers know this, which is exactly why Clipper malware was invented. Microsoft's threat intelligence team actually tracked a Tor-routed crypto Clipper doing exactly this in the wild. The malware uses code patterns, regular expressions, to scan your clipboard every 500 milliseconds, every half a second. If it detects a 34-character Tron address starting with a T or a Bitcoin address starting with a 1 or 3, it intercepts the clipboard instantly. It replaces the address you just copied with an address controlled by the hacker. And the truly terrifying part, the malware actually tries to match the first few and last few characters of your intended address so it looks visually similar at a quick glance.
If you just hit paste and confirm without verifying the whole thing, you've just willingly handed your crypto directly to the attacker. No way around it.
Section 4. Address poisoning and toxic approvals. This is exactly why you can't even trust your own transaction history logs anymore.
Attackers have evolved past just infecting your computer. They're now infecting the blockchain records themselves through address poisoning. They're basically hoping you'll lazily copy an old address from your transaction history. Here's the scenario. Say you frequently sent crypto to a friend. A hacker uses software to generate a vanity address that perfectly matches the first 5 and last 5 characters of your friend's wallet. They then send a $0 transaction to your wallet from this clone address. When you go to send money to your friend next week, you look at your Block Explorer history, see an address that looks perfectly familiar, copy it, and send the funds. But the middle characters were completely different. Boom. You just got poisoned.
And here is a massive misconception in the Web3 space. Simply disconnecting your wallet from a website is not enough. When you interact with a decentralized app, you often sign a transaction granting an unlimited spend approval just to save on future gas fees. But if that smart contract is compromised later on, the attacker can use that active approval to reach right into your wallet and drain your tokens without you ever signing another transaction. You have to actively use tools like revoke.cash or block explorers to explicitly audit and revoke these allowances on the blockchain, resetting the limit to 0. Disconnecting leaves the door wide open.
So, how do we fight back? Section 5, the fail-safe sender protocol. These are the non-negotiable micro habits you absolutely must adopt.
This checklist is a game changer. It transforms anxiety into confidence by guaranteeing you never send your entire balance blind. Step 1, always verify the chain. Are you sending over Ethereum mainnet or an arbitrary layer 2? Step 2 defeats Clipper malware and address poisoning simultaneously. You must visually verify the first 6 and last 6 characters of the address directly against the original source screen, not just what is sitting in your clipboard. Step 3, double check for any required memos or destination tags if you're depositing to a centralized exchange. And step 4 is so important it needs its own slide.
Dust routing. This is where you execute a minimal test transaction to validate the entire pipeline before routing the high-value transfer. Never, under any circumstances, send 100% of your intended funds in a single initial transaction. Just don't do it. You send $5 or $10 first. You track the transaction ID on a block explorer like Etherscan or BSC scan. You wait for those block confirmations, and only upon successful receipt confirmation by the receiving party do you go ahead and transfer the remaining balance. And yeah, I know you pay gas fees twice, but honestly, consider that the cheapest insurance policy you will ever buy.
Wrapping up with Section 6, securing your digital vault. Because honestly, everything we just talked about doesn't matter even a little bit if you just hand the keys to the castle directly to the enemy.
True self-custody requires moving way beyond basic software wallets and into cold storage solutions like a Trezor or a Ledger, where your private key literally never touches the internet. First rule of Web3, and you know this, never ever share your recovery phrase. No support agent will ever ask for it. Do not take a screenshot of it because cloud services get hacked all the time. Write it down. And a stark warning for you, if you ever notice that your Ethereum is being automatically transferred out the very second it enters your wallet, your seed phrase has been compromised by what's called a sweeper bot. Do not try to save it, don't try to revoke approvals. That wallet is dead. Abandon it immediately and start fresh. Lastly, secure all your exchange accounts with unique passwords from a password manager and use a dedicated 2FA authenticator app. SMS text messages can easily be SIM-jacked, so stay away from those.
The ultimate takeaway from today's explainer is that in the dark forest of Web3, your digital hygiene is literally the only thing standing between your wealth and total loss. The blockchain is a phenomenal innovation, offering unprecedented financial freedom, but it relies entirely on your diligence. By verifying networks, triple-checking your addresses, running test transactions, and protecting your private keys offline, you are closing that vault door. You're taking control. So I'll leave you with this to ponder. The next time you hit send on a transaction, are you just hoping it gets there? Or do you know for an absolute fact that your protocols are unbreakable?